Okay, so g'day, and anyway, welcome back. Today we are in a new estate, Wallen, and as you can see, all the houses behind me are actually fairly new and also fairly large. So these are actually probably, I would say, cost $1 million. But we're not here for the housing. Are here to look at the geology. So a lot of what you see me now in the front of me is actually artificially being made, and a lot of this has been altered as well. But basically this is all basalt derived soils, and they're black soils. So there's two types of soils you get in Melbourne. You get the red and the black. The blacks are recent soils, have a lot of organics and still have a lot of the original elements that are in them, magnesium, titanium, stuff like that. The red soils have been leached, so they're a lot older and usually a lot thicker, over 1 metre in depth, and a lot of that is just iron oxide. So here we have a creek, and this is the actual soil derived from basalt. So what we have here, well, we have a creek down here. We have basalt flows that originated probably about 1 to 2 million years ago. Although most of this basalt rock has not been dated. I think only the scoria cones, which they come from. But this is not all scoria cones. It probably would have been fissure volcanoes. There's not many Mars around here, which are just big holes in the ground. You need to go towards Ballarat for that, and even after Ballarat. So we have quarry hills. So this is supposed to be a nature reserve, but I think some of it's going to be housing. Probably housing is going to be over that way. But what I am looking for is the actual cutoff between the basalt and the actual siltstone. So this is 1 to 2 million years old, as I said before, and when they've excavated, you can actually see a lot of the basalt boulders. So this is vesticular, lots of holes in it, also vesticular. So this is a top of flow where the gas wasn't able to actually get out in time. There's a lot of rubbish from construction. We have drainage here, so all of this would have been excavated. So this is not. And also that exit for the actual creek has been excavated. So even this creek has been altered somehow. But at least actually planted some plants. Okay, and the hills in background, you think, oh yeah, that's a volcano. No, they are the Melbourne Formation. So those are about 423 to 419 million year old rock. So got a lot of information. It's part of the Murrindindi supergroup, so it includes a lot of rocks in central Victoria. So above this, obviously there is no rock above this, but we're talking about up north. It's a Hume Formation. So this is actually should be dipping to the east, and underneath this is, well, they call it the Yanyun Formation, or used to be. But now it's part of the Melbourne Formation, so it should be the Yanyun member of the Melbourne Formation. And underneath that, which you need to go down south, is the Anderson Creek. So, and they're all similar in age. It's siltstone, sandstone, some shale, mudstone. If you're going to find fossils, it'll probably be in the shales or the sandstones. So you do get a lot of starfish, trilobites. Actually, trilobites are in the sandstone. Oh, dragonfly or damselfly, which one? So this one's actually blue. Looks quite beautiful. Okay, so that's enough. Have a look at my ugly mug, and well, at the moment I don't see any of the contact zone. So what I'm thinking is that you have the actual lava coming in, probably damming a previous previous watercourse, which will be delineated from the actual erosion that you can see in the rock, and by the fact that this lava is only about 5 to 10 meters thick, so obviously the watercourse is probably over that way. Okay, so here we got an old road, and here is the Darabin Creek. So this is the spillway, and what I can see over there, I can actually see the actual siltstone. So the contact zone is somewhere here, and we do have some basalts here, so the contact zone is probably around about here somewhere. So we do have basalt, but that could, it's probably a bit big to actually be imported. And you can just tell by the actual soil that it's changed. So roughly around here is the actual contact zone. And you can see that the actual river is in the same position as the contact zone. So obviously this was the weak point in the rock, which the water has exploited and used it as an area to flow in. So essentially this is the weakest point that's been eroded, and you can see from the soil profiles the weathering is quite deep. So on that side we have the Silurian siltstones, here we have the contact, and over there we have the basalt. So that's very interesting. And I reckon if you follow this creek all the way down, a lot of the time you're going to find the actual contact, which is just flowing wherever the weakest point in the rock is between the basalt and the siltstone. Although you get some flat areas which are probably just have a lot of river flood deposits, so alluvium. You're not going to find fossils here. You're going to find a lot of kangaroos over there though. Okay, and there's an old tree, it's probably 500 years old or so. And if you look on the side of this riverbank, you can't really tell the soils because it's just so heavily weathered. Okay, so we just dinky die yobbo lovers. I will just go down the actual creek and we'll see if we can find any other type of contact. Seems to be a bridge over there. And this basalt derived soil is just horrible because why? It just looks horrible. There's lots of rock in it. The actual properties of the Montmorillonite clay is pretty bad. And also, it's a nice warm day, you might be able to see a snake. So the snakes we have around here, we have brown snakes, copperheads, and those two seem quite similar, but if you're experienced you know what you're looking for, but they're still dangerous, so can't walk in there, or else I'll just walk in the river. We have red-bellied black snakes, so they're pretty much black. They have a red belly, although not always, sometimes they have a black belly. That seems to be placid, but I still wouldn't mess with it. And gee, there's another one, tiger snakes, that's it. Now tiger snakes, obviously they're banded, not always, sometimes they come in black, or browns, but they seem to be not as aggressive as brown snakes. So in this environment here, around here I expect to find black snakes, red bellies. Around here in the dry areas probably more find brown snakes and copperheads, but obviously they move, so the preferred habitat is not 100%. Obviously, all this is serrated tussock grass, pretty much a weed. Now I don't know what grass that is. Obviously we've got thistles. These only thrive on recently abandoned farmlands. Over the long term they won't be able to actually survive here, especially in native forests. But this serrated tussock grass does, but obviously over time it gets taken over by different types of grasses. A lot of mustard. In this tree, lots of native birds. Now they're not sparrows. I don't know. Maybe a goldeneye. They like this type of plant. This tree, it's actually quite large. I would say the diameter is probably 3 meters. So I'm going to say that this tree is over 500 years old. Which is amazing. And we have a skeleton of an animal. Looks like a cranium. It looks like a cow. Oh, look at that, beautiful. So this is probably, I don't know, my eucalypt species. Could be, no, it looks like a yellow box or yellow gum. One of those two. I always get confused with those. So, which is pretty common around here. Okay, so here we have the bridge. Obviously it's quite old, sheet metal. So this looks like it was cut from a former, like a cylinder, probably a steam engine or something. Fairly rusted, so I'm not too sure how stable it is. Obviously this is starting to crack and fall down. So obviously this is the siltstone over here. And this is the basalt. If you have a look. Yeah, that looks a bit silty. It looks a bit basalty. Look, they pinned it because they knew it was cracking. So basically this is still the contact zone between the basalt on the right and on the left is the siltstone. So we have some basalt there. Looks like we've got siltstone there. So obviously if you're looking for rock, you need to also look for soil. No, that's cement. So this is obviously yellowish, and it has a lot of iron oxide concretions. So this is pretty common in heavily weathered soils. So this is caused by the actual supersaturated water in iron. And when it evaporates, it enucleates around something, and over time it builds up these large blocks, and it also can build sheets in the actual material. So it's just everywhere. It's just part of the soil horizon. It's not part of the actual rock itself. So anyway, we could keep on going up that way, which I don't really want to. But that's basically it. Over the other side we have granite. This is South Moraine granite. And this is all fairly recently acquired. Don't know why there's a no-go zone. Recently acquired for land for the park. Anyway, here we have some siltstone. Obviously it's iron and durinated, so it's actually quite hard. It's pretty hard to smash with a hammer. So basically, that's just subtle hints if you want to look at the actual geology of a place. Obviously you need to know a little bit about what soils that rock does produce. So, gee, I hope I don't fall through walking over this bridge. Yeah, so you know what geology could be under there. Now the soils could be transported from one place to another. It'll cover up the actual original rock, and the original rock soils probably are not in place. So we see that with the Shepparton Formation. So that all comes from the Ordovician rock, and as it erodes, it's just covering over the previous rock, which is probably also Ordovician. Could be earlier, could be Cambrian. Don't know. I haven't seen any core samples. Anyway, hope this helps you. What a beautiful day.